Hi guys, today's notes are on quadratic inequalities, section 3.6 in your textbook. So let's first define what an inequality is. A quadratic inequality is just like a quadratic equation with an inequality symbol instead. So what is an inequality symbol? Well, inequalities are, instead of like an equal sign for equations, you have less than, greater than, less than or equal to, and greater than or equal to. We'll talk about those a bit more. A solution to an equation is a single point or value, right? So like we get like x equals 2. But solutions to inequalities are an entire shaded area or region. So like if we have like x is greater than 2, then all the numbers greater than 2 are possible, starting from like 2.1 to 2.2, 2.3, right? And an infinite number. You could even do 2.01. So it's an infinite number of solutions, but it's not all the infinite number of solutions. So it's sum of, it's not even sum, it's infinite solutions, but it's defined, right? So let's call it defined infinite solutions. So you can't say all real numbers, is basically what I'm trying to say. And so let's take a moment and talk about what these are. You can graph an inequality in any form. So it could be standard form, vertex form, intercept form, but you're going to have greater than, less than, greater than or equal to, and less than or equal to. Now, how do I know which is which? If you hold your hands up like this, okay, your left hand is less than. So that's this one. And it's your left hand. I don't have a trick for the right hand, it's just the other, so that's greater than. If there's a line underneath, then it's less than or equal to. So what's the difference? Well, if it's less than 2, then 2 is not an option. You have to go less than 2, like 1.99. If it's less than or equal to 2, then it could be 1.99 and anything lower, or it can be the number 2. So you're first going to graph the parabola with the equation as if it were normally a quadratic. Okay, so you're going to make the parabola, or the line for the parabola, dashed for inequalities with less than or greater than. So notice it's not equal to. So if it's not equal to that point on the parabola, we're going to use open points. Like this, okay? Because if I like plot a point, that point is going to help us define where the parabola is, but that's not part of the solution set. If it is equal to, then we can use solid lines and closed points like we've normally been doing. Okay. Once you do that, you're going to shade a region. Once we have our line, we're going to shade a region that makes an inequality true. If it's less than or equal to, you're going to shade below. And if it's greater than or equal to, you're going to shade above. So let's take a look at what this looks like. Okay. So notice that we have two graphs. They're exactly the same. They're both dashed. And then one is shaded below, one is shaded above. I really wish I had like 4 of the same graph with like the 4 different options and solid lines. You'll notice that these two have solid lines. So right away, I know that these two must be B and D or D and B. Okay. It also helps because we know it opens down. So there's a lot of hints that you can take a look at. Here, we are going to notice that this is y is less than, right, these. So the solutions we want are all the y values are less than this line. So that's this one right here. Okay. And so this one must be all the y values that are greater this line. Okay, so that's C. Now as I do it, I should cross off when we're matching. Take a moment and see if you can match up the next two. You should get D and B. Okay. So what does it really mean, and why is the line dashed? Well, when you get a point, let's plug in, they all have y-intercepts of -8. Would you agree? So let's plug in this point and see what's happening here. So at this point, and I'm going to do it for this one and this one. Okay. So at this point, if I plug in 0, -8 as my x and y, I'm going to have y is -8 less than 0 squared plus 2 times 0 minus 8. And then you'll get -8 is less than, this is all 0, right? -8. And that is not true, because -8 is equal to, but it's not less than. So then once you have that, you know that this point is not true, and you can have an open point there. And so since it's not true, you can't color that solution in, and you have an open point. What you're going to find here is that we have the same numbers, right? So you're going to get -8 is less than or equal to -8, which is true. So this point you can fill in because that's a solution, versus this one is not a solution, so you can't fill it in. Now let's take a moment and graph each inequality. So since it's less than, not less than or equal to, we know we're going to have open circles. Okay, no equal to. It's going to also be dashed, right? Because it's not a solid line. All of those points are not valid, and we're going to open down or shade below because it is less than. Okay. So let's take a moment, since it's going to shift up to, okay, it's an open circle. Notice I didn't shade it in, although it looks a little shaded, sorry. And then we know that it's going to open up 1 over 1, 1, 3, and 5 doesn't fit. Okay. So everything is still the same, and when you do your dashed line, just make sure you don't connect it with a solid line. Okay. That's our graph so far, and it has to be all points less than x squared plus 2. So it's going to be all these points. So that means if you plug in any point down here, it will make this solution true, or this inequality true. If you pick a point up here, it will not be true. Okay. Vertex form is the same thing, so you can take a moment, graph it, and it should be greater than or equal to, which means it's going to be a closed point with solid lines. And we're going to graph. So take a moment, see if you can graph this. Okay, so I graph my vertex at -4, -1, and then my first slope is -1 over 1, so that's my pattern multiplier, right? So here's all my points, down 1, down 3, down 5. I'm going to connect it with a solid point, and it's all y is greater than or equal to, so greater than or equal to is everything up here. This last one's the trickiest because it's standard form, which is the hardest to find a vertex. Hopefully you remember. Quick review. -b over 2a. So we're going to plug in -4 over 2 times 2, which is -4 over 4, which is -1. Plug in -1. And let's see, that's 2 times +1, which is 2, minus 4, plus 1. Negative 2 plus 1 is negative 1. So my vertex is negative 1, negative 1. Take a moment, see if you can figure out if it's open or closed. Since it's not equal to, it's open. And my pattern is 1, 3, 5, right? And hopefully you know that the multiplier is 2. So it's going to be 2, 6, 10. So up to 1, 2, 3, 4, 5, 6. Dash line. And it says less than, so it's going to be the big area below. Hopefully that all makes sense. We're going to do the same thing now, except instead of finding where just one inequality is, we're going to take a moment and put both of them on there. So let's see what we got. Okay, so I'll do it in different colors so you guys can see it more carefully. Okay, this is less than or equal to, so I can do the solid line. Now this is where like shading in all the way doesn't help as much, and having two colors is more helpful, okay? Because what you're going to see now is I'm going to start at up 3, 1, 2, 3. It's open because it's greater than, and so I'm going to go down 3 over 1. And we're starting to get really close. Our pattern is 1, 3, 5. So I'm going to times negative 3. That'll be negative 3, negative 9, negative 15. So negative 9 is down here. Okay, so this is where, like, if I wanted to shade the second region, it would be a little bit messy because everything above or outside of that parabola would get shaded, but we're looking for the double shaded area. So that would be in here. And that would also be in here, okay, because we're going to shade above. So that double shaded area is your solutions. Okay. Take a moment, pause here, see if you can get your final answer. Okay, so here are the solutions. I did make a few changes on your sheet. So just keep in mind that these double shaded regions are what we're looking for, right? So this gets a little bit messy. So at the end, when you've double shaded, notice I use like crisscrosses where I go like up first and then double, and then I just like go through and shade at the very end. It gets a little messy when there's no solid line, but it's okay. Just point an arrow to the final solution. If it's in standard form, you do need to use negative b over 2a. I made this one a nice whole number. This one was nasty, but decimals are okay. I use decimals, not fractions, on a graph because fractions are not helpful on graphs. Okay, when I do quadratic formula, leaving it as a fraction is fairly helpful. So now let's solve the inequality algebraically. Okay, and this one's a little bit interesting. So we're going to solve as if everything is exactly the same. We're trying to get x by itself. There are a few rules. Okay, the most important one being when you divide an inequality, when you multiply or divide an inequality by a negative number, you need to flip the symbol. So instead of less than, it becomes greater than. Okay, and why is this? Well, because I guess I can show you on the side. If I have like x, let's use some actual numbers. Ready? So let's say 0 is less than 2. Well, if I multiply by negative 2 and negative 2, let's do negative 1. and -1. The numbers I now get are 0 and -2. Do you see how 0 is not less than -2 anymore? When you flip a negative or multiply by negative, your symbol has to switch and it becomes 0 is greater than -2. So this sort of just shows you why it works, and that it proves that it does work. It doesn't necessarily show you why, but the why is because if you flip the signs, then you have to switch the symbol. So let's, knowing those two, start solving. We're going to divide by 16 first. Okay. Notice these are all single variables, so we're just solving for x here. You always should divide by the number in front, coefficient first. Okay, so this will be x squared is greater than, oh goodness, 100 over 16. I don't know that it's divisible, but I know I can do divide by 4, so that'll be 25 over 4. So now you want to take the square root of both sides, but it's really important that there are two x's, right? So you take the square root of both sides, and then that gives us x is greater than plus or minus, let's see, square root of 25 over 4, which is x is greater than plus or minus 5 over 2. Now, this is really important to like visually understand what this is saying. This is saying on a number line, here's 0, I have positive 5/2 and I have negative 5/2. And I want the x values that are greater than these. So greater is over here. Would you guys agree? Okay. Now, the problem with greater than a negative is that technically the x value that's greater is on the outside. So we want the two that are pointing away. And so you can't write your answer just like this. You have to write your answer as x is greater than 5 over 2. Oh, I should do that for this side. X is greater than 5 over 2, right? That's that one. And then on this side, we want the values that are less than -5 over 2. And this again has to do with like that negative and the flipping thing, right? So if you have a negative, then I should flip the sign. So if you multiply by a negative, flip the sign here. This means that this inequality has two portions of the graph, and they are both part of the same solution. Okay. So let's take a moment and solve this one. Notice this one has an x squared and an x, so I can't solve by square roots anymore. I need to solve by factoring or quadratic formula. So I'm going to move everything and get it equal to 0. So we will now have x squared minus 15x plus 34 is less than or equal to 0. Okay, I took the inverse operations of each one. And so I always check for multiplication first, or factoring first. So what multiplies to 34 and adds to -15? Well, I just know this one. It's going to be 17 and 2. So it'll be -17 and +2. If you didn't know that, then yes, you could use the quadratic formula. I think you'd just be a little sad. Okay. And so both of these are less than 0, so we'll have, let's see. Is that correct? Oh no, this doesn't work because it's a positive. Well, that sucks then, because now we need to use a quadratic formula. If only I had done that better. Okay, so let's do it. Ready? X is less than or equal to. Let's not even do that. Let's pretend it's equals for now, and we'll talk about what we do when we have things like this. So it'll be -15 plus or minus b squared minus 4 times a times c all over 2 times 1. It's 15 plus or minus 225 minus 4 times 34. Let's just make sure I'm not messing up here. 4 times 34 is 136. 225 minus 136 all over 2. That equals 215 plus or minus 89 over 2. And so at this point, you are going to have, we know that it's less than. So I guess I should write in our less than. Less than or equal to, less than or equal to, x is less than or equal to. So what is x is less than or equal to? Well, x is less than means that you want, instead of the pieces that are outside, you want the pieces inside. Okay, so since we want the pieces inside, we need to check to make sure that which one is smaller. We have 15 minus square root 89 over 2. And I should probably check that that's a smaller number. How do I do that on my calculator? I'm going to go 15. Sorry, let me pull this up. Okay, 15 minus square root 89 divide by 2. That's 2.78, and then I'm going to go back and just make sure that its plus is bigger. Okay, makes sense that it should be, but I just want to be sure. And so this is the bigger number. And so what you need is you want x's that are in between these values. So this is a smaller number, and this is the bigger one. So let's read it out. X is greater than or between the smaller number and the bigger number, and you want to make sure that you have less than for both of them. Okay? So our last one, if you want to try this by yourself, go for it. It's the same idea. You're going to set it equal to 0. I would multiply. But since we are setting it equal to 0, I would assume you guys would move it this way. And then add 25 is greater than or equal to 0. So we know it's going to have two pieces, right? Because anytime it's greater than or equal to, we're going to go this way. Ooh, actually no. Trick question. You guys ready? I'm going to multiply by -5 to get rid of this denominator. And then technically this is times -5, but 0 times -5 does nothing. And remember that when you multiply by negative, you must switch this sign. Okay, so it's no longer greater than or equal to, it is less than or equal to. And so now we need numbers that multiply to -125 and add to 50. Those numbers are too big for me to know off the top of my head, so I'm going to use the quadratic formula and hope that it works out. -50 plus or minus square root. Okay, so maybe pause the video here and see if you can do this yourself. Make sure that you have 50 squared plus, oh sorry, lost a 0, plus 4 times 125, so that's 500, all over 2. Okay. So it's sort of a pain because how do we know what we're going to divide by? Well, let's start with 4 and see if it works. Oh, I know, 25 probably will work, right? Because it's a better square. So 3,000 divided by 25. That's 25 times 120. Well, I can keep going because I see there's a 4 in there. So this will be 5 times 4 times 30. 30 is not factorable in any way, shape, or form. It is, but it's not going to give you a perfect square. so that'll be 50 plus or minus 5 times 2 is 10, sorry, root 30 over 2. Now we can divide all of our outside numbers by 2. Okay, don't mess with the 30, that's a decimal. And so it's less than, so it's going to be in between these 2 points, and we are going to have 25 minus 5 root 30 is less than or equal to x, which is less than or equal to 25 plus 5 root 30. All that work for 1. Okay. Last one. Ooh, this is a bit longer. I'm going to pause here and we'll do this another day. Okay?